This lecture we will learn about the application. First of all, we will learn about the definition of machine learning, then different examples where machine learning is used and where it can be used, how it is used, what are the requirements to use machine learning. Introduction. Someone has turned on the mic. I request to kindly turn it off. Kindly turn off your mic. So machine learning is the emerging field in RSGIS. Though machine learning is concept of machine learning is very old, started way back in 1950, 60. That time concept came, but implementation wise it was lacking. Then later on implementation came, but computation wise we were lacking. Now we are having implementation as well as computing power, both. So that is one of the reason that many people are into the machine learning and AI field. Application of machine learning other than RSGIS came even uh, before RSGIS. Uh, it came, we have seen about the artificial intelligence, Sophia robot, citizenship for the first citizen, first artificial intelligence based citizen. So that kind of things we have seen, which means AI were there, but in RSGIS it is emerging field. Sometimes machine learning term is used interchangeably with artificial intelligence, but they are not same. Machine learning is part of artificial intelligence, and difference is in case of artificial intelligence, basically artificial intelligence enables machines to mimic human behavior. So it it replaces the human thinking. However, in case of machine learning, it is the statistical methods which learn from the data, build the logic, and does the job, perform the task. That is the slight difference between machine learning and artificial intelligence. Again, someone has switched on the mic. I request to turn it off. So let's come to definition. Machine learning is a method where generic algorithms learn from the data and tells you some interesting facts about the data. It reveals the pattern, it predicts the future. Means learning can be in the form of revealing the pattern, classifying, classification. It can be the forecasting, predicting future using time series data. That kind of application can be there. Then identification of some particular person, some face from the live streaming video. So there are a lot of applications of machine learning, but basic requirement is learning. So here for learning, for machines to learn data and a lot of data, different variety of data is needed for training of the machines. So machine learning is a technology designed to build intelligent systems, and these systems learn from the historical data and provide results as per training. If you are training your model to do the classification, it can be classification in uh, four classes, for example, land, uh, urban, cropland, forest, water body, that these many classes. It can be even more classes, deciduous forest, needle leaf forest, broadleaf forest, evergreen forest, mixed forest. So that kind of subclass classification can also be done. It and it depends on the kind of historical data or kind of the training data being provided. Advantage of the machine learning is problem specific code need not to be written, which means you don't need to write a code to do classification. You don't need to write the code to identify a face. You don't need to write a code to find out uh, any kind of pattern from the data. The algorithm is generic. The only thing is you need to feed the data. If you are feeding the data for classification, it will do classification. If you are feeding the data, or if you are feeding the training data for, if you are feeding the data for face identification from the video, it will do face identification. If you are doing feeding the data for sentiment analysis from the on the social media, so it will do sentiment analysis. Same algorithm, same, there are certain algorithms like random forest, uh, neural network based method, support vector machine. So method is same, algorithm is same, only learning training data is different. So advantage is, instead of writing problem specific code, you need to feed the data to the algorithm. Logic it will build. The real world some of the real world applications of machine learning are, there are many users, many, or I can say that all of you are online, all of you must have done online shopping someday at least. So while shopping, interest of each person vary with respect to uh, type of shopping, product type, basically product category, the brand, the color of the product, price range of the product, manufacturer of the product. So these things vary person to person, but you will notice that after searching for some product online, just open the Chrome and search for some product like laptop, Dell laptops. If you do this kind of search engines as well as social media, they will start giving you recommendation of different kind of similar products in the price range you have searched. So that recommendation is based on machine learning. There is no one sitting and writing a custom code for every user. Uh, Based on browsing history of the user, the algorithm learns, and according to the learning, it starts giving a recommendation. Same concept is used in case of movie recommendation in Netflix. So if you watch some movie, it will start showing you the movie with the tag that there is 98% match or 80% match, 82% match, 100% match. That kind of recommendation you will see in Netflix. Even you open any movie, it will show you the percentage match. That match is with the type of movie you watch. That match is generally the score of the algorithm. So based on your genre, uh, based on your choice of genre, actor, I don't know exactly what parameters it uses, but based on something, it suggests you the recommendation, and recommendation suggestion is based on machine learning in case of Netflix. Applications are very vast, like voice recognition. So you can do wonders with applications of machine learning. Sometimes you may need to identify a person with using his voice. Maybe some crime detection agencies need to search in the database, voice database, to search some person identification. They can, if normal searching is based on if else logic. So sometimes it fails, sometimes it matches. Uh, but in case of machine learning, it is not strictly based on if else logic. Many steps are there in the algorithm. Based on that, matching is being done. The email spam detection filter. So you can notice in your Google image inbox, Gmail inbox, some of the emails will come with the tag spam. So that, and sometimes or rarely you will find that the email was not spam. The recommendation for spam is done using machine learning, and it learns from the uh, patterns, and you can train the improve the model. Suppose it is some, you are getting some email without spam filter, so you can tag those emails with the name spam. So this way, if you start tagging the spam mails, non-spam mails as spam, and this way, uh, model will improve, and in future, the better recommendation of spam will come. Then image processing, it can be like performing the classes classification in satellite imagery, uh, extracting the objects from the satellite imagery. Machine learning can help you. Sometimes, as you know, all of you must be user of Google Map navigation. So suppose some new road comes in any area and it is not present in Google Map. So one way is someone manually updates that road in Google Map, or someone manually sends the recommendation for update in road in any area. And there is another possibility that the algorithm automatically uh, identifies the object or new object from the satellite imagery, and it gives a alert that there is new road, new object in this, it should be included. So that kind of recommendation is also possible. A face and image processing, machine learning can be used for automatic traffic challans also, traffic fines also. So you may have heard that sometimes uh, different vehicle gets a ticket for overspeeding, which was not actually on the road that day. But this thing happens because of some error in the processing systems. Those systems can be improved so that this kind of errors does not happen. So this improvement is possible with the help of machine learning, because currently the traffic cameras has to work in different weather conditions, like daytime, nighttime, cloudy weather, rainy season. So you can train the algorithm to work efficiently in different seasons, in different conditions, day and night, so that this errors does not happen. So nowadays, generally, the image processing recommendation are supervised by some supervisor. Then only tickets are issued. It can be done in efficient manner with the help of machine learning. The face recognition. So sometimes you may have seen that a face of particular person, you may have seen in movies that a face of particular person is being searched in the live feed from traffic cameras. So that kind of system can be built with the help of machine learning. The continuous monitoring of video feed. So uh, if you have to monitor some video feed for unlawful activities, for example, even if uh, CCTV's cameras are installed in building, around the building, surrounding the building, inside the building, and security personnel in security room uh, observes uh, the camera feed, CCTV feed, they sit in front of the screen and they need to monitor what is happening. If something irregular happening, then they need to take the action. But sometimes it becomes difficult to sit in front of the screen and watch multiple cameras, multiple screens. So to avoid uh, human errors, manual errors, a system can be built which will alert every personnel if there is any irregular activity starts happening in the vicinity of the CCTV region. So there possibility of machine learning exists. Then detection of financial frauds, machine learning can be used. Financial fraud means uh, swiping of card. So if certain system can be made which can detect that there is fraud in card swiping, so it will block the transaction immediately. Then sentiment analysis. Nowadays, there is a lot of social media, Twitter, Facebook, Instagram. So here, a sentiment analysis uh, can also be done with the help of machine learning. Means what public wants, what are the tweets about some particular uh, policy. So suppose a government uh, tables a new bill and it wants to know that what general public is thinking about the bill. Let's say population control bill, what public is thinking. So traditional way of knowing this, you put the bill on the website and let the public come to website and comment or send a letter to the government, to the concerned ministry. So this is the passive way of knowing the sentiment. But with the help of machine learning, sentiment analysis can be performed uh, to analyze the tweets. So because generally people do not go and vote on the website for the bill, do not go on the website and write their views, do not send a signed letter to the ministry. Some people do, but for general public, so it is one of the application of machine learning where analysis can be performed to know about the public opinion from social media platforms, because public prefers to give opinion where accessibility is easier. So the sentiment analysis is very important. Then difference, what is the difference between rule based or traditional method versus machine learning? So traditional method takes data as input and program a logic also need to be given as input, and based on data as well as logic it gives you the output. So in traditional programming you need to give data as input, then you need to give if else kind of logic or program you need to give as logic, then it will give you output based on the program, based on the conditions logics you have written. Based on that you will get output. But in case of machine learning, you don't have to give program as output, you need to give data as input, and output itself you need to give as input, which means a training data. From the history you will be knowing the output of some input data, also known as training data. So from training data there will be some input component and there will be output component that you need to give to machine learning, and it will give you program as output. At the later stage you need to feed data to this program only, no need to do these things again. So once you get the program here as output, at, so this is the training process where you give input data and output, means from training data you give data input and its labels, you get the program. So training ends here. After you get the program, at the later stage you will simply give input data here. Here you need to give input data, and this program will give you output. This program will give you output. So example with respect to brain, like students feed their brains with high quality data, high quality questions from different sources. So during this process their brain basically gets trained to solve different kind of questions. So each time student solves a practice test and find the performance by comparing with answer key, the performance of the student gradually increases as the model learning improves. Model basically brain learning improves. So in this process, a machine can be thought of as brains, and question or high quality questions can be thought of as data. So similar concept is being used in machine learning, where you need to feed a large amount of training data to the machine, to the computer, and based on data and its output, it will learn and produce a model. Later on, you need to feed the data in the model, you will get the output. So during the training process, fundamental assumption is that the training data is identical with testing data and any other data to be used in future as input. So this is generally expected. So suppose in this process, if brain is getting trained with some kind of question, and in exam out of syllabus question comes, student will not be able to solve it because the brain is not trained for out of the syllabus questions. So it is expected that this is the defined syllabus, and from this student learns the questions solving process, and questions will be subset of this syllabus only. But if a question comes from out of the syllabus, student fails to answer. So the same concept is in machine learning. If training data is not identical with the future data to be used, model will not be able to learn. Since model, if model has not seen the uh, data previously, or since model has not seen that kind of data previously, it will not be able to classify, it will not be identified to produce correct output in future. So this is the basic assumption, and obviously 100% identical distribution of training data and future data cannot be expected, because presently we have the data from the history, and in future there is a high possibility that the new data doesn't follow the exactly identical distribution. Some deviation from the previous structure is possible, but it should not be completely different. So like if your training data is following Gaussian distribution, your testing data or future data may deviate up to very limited deviation from the Gaussian distribution, but it should not be completely different. And if it is different, you will see that the accuracy of model is lesser. So poor accuracy of model will be seen. Training data is always expected, and it is always preferred to have a high quality of training data set, because it is the representative of testing data or any unseen data. So if the representative data is better, then only it can perform a better pattern identification. So how machine learning works? It starts with a data collection process. Then we need a lot of pre-processing of the data, because in case of machine learning, everything goes in the form of numerical numbers, numerical data, not nominal data. So if there is nominal data in your input data set, you need to remove it first. Like if you will search uh, application of machine learning, you will find a very good example from the Titanic Kegel data sets, I think. So there is one question, uh, which passenger will die? What is the possibility of dying a passenger? So that kind of analysis is being performed. So the dying relationship, who will die first, is related to who is living where, in which room someone is, in which block someone is living. So blocks are categorized as, for example, A, B, C, D. So A, B, C, D cannot be given to model. We need to convert them to numbers. And there is a possibility of blank values in the data set. So those blank values need to be removed. So this kind of some data pre-processing is needed. So once data pre-processing is done, splitting in test and training set is needed. Why splitting is important? So it should not be that any how you are choosing the training data set. As I told previously, training data set is the good representative of future data or testing data set. So to make a good representative, it should belong to different variety of the testing data set. So it should not be like, suppose you are having 100, suppose you are having 1,000 rows of testing data set and you are simply choosing top 10 rows as training data set. So that way you may cover the biased data and it will result in poor accuracy. So what I mean, suppose your overall data is following Gaussian distribution, and suppose for training data set pickup, you simply pick data from this region only. So what will happen? Data from this region will not be seen by machine learning. So if machines are learning or algorithm is learning because of this data only, so it will act according to this data. So but later on, when you will start feeding data from this region, it will result in poor accuracy. After training, a very important step is testing the performance, because based on the testing of performance only you can claim that your model is working well and it can be used for the specific purpose. So always it is not necessary that machine learning is the preferred method. Sometimes statistical methods may be better. So it depends, and the claim can be made based on performance testing only. There are few basic terminologies in case of machine learning. So whenever you will read any literature, you will find these terms: model, feature vector, target, training, prediction. So these terms. So anyway, training, prediction, they are uh, even common word. Target or label, that is little different. Feature vector is also different. So whenever uh, anyone is saying or anywhere it is written model, model means specific representation or learned specific representation learned from data by applying some machine learning algorithm. So random forest is a algorithm, and when you train this algorithm you get a model. So it is specific representation learned. So the representation logics learned from the data by applying some machine learning algorithm, that is a model. Then feature, individual measurable property of the data. So that is a feature. For example, when you are classifying, you want to classify image in land use land cover classes with a multispectral image. So uh, uh, so for any class, pixel value in each band is a feature. So pixel value of red band is a feature of cropland. Pixel value in green band is a feature of Cropland, pixel value in NIR band is a feature of cropland. Pixel value in red band is a feature of cropland. And combinedly, we call all these features a feature vector. A set of numeric features is conveniently described by a feature vector. Feature vectors are a set of features, and this feature vector is fed into the model as the input. So, feature vector is input of the model. Then target or label. So, this is the value to be predicted by the model. So for land use land cover classification, pixel value in RGB and IR bands, they are feature vectors, and which class it belongs to, that is the target value. For example, cropland. So cropland will be figure of that particular set. Then training. Training is the process where machine learning algorithm learns from the data. Prediction is getting the output from the model. So in the prediction process, the feature vector is fed to the model and it gives the output. In types of machine learning, there is a supervised category, unsupervised, and reinforcement learning. Supervised means you are creating, you are supervising the model. Basically, you are giving the feature vector, you are giving the label. But in case of unsupervised learning, you do not provide the training data, so it learns the pattern without training data. So also these algorithms are also known as classification as well as clustering. So supervised is the classification method, clustering means grouping, is a unsupervised learning method. Like what if you want to reveal the pattern of clustering, like what are the areas heavily affected by COVID cases? So if that kind of region identification need to be done, that comes under clustering, where we do not know about the classes. So in those cases, unsupervised learning or clustering is performed. But when we know about the classes, like land cover classification, or supervised algorithms performed. So why do you need machine learning? So these kind of questions you need to ask when you have to decide, can you apply a machine learning? So wherever question comes in mind about application of machine learning, you need to have answer of these things. Why do you need machine learning? Machine learning is preferred in the cases where the relationship between the input and output is not clearly defined, or if whenever there is a non-linear kind of relationship between the input and output. So in those cases, machine learning can learn the relationship, and accordingly calculations or prediction can be done. So like rainfall prediction of groundwater levels. Uh, so these things are uh, not linearly related with any kind of input parameter, like uh, groundwater level. It is groundwater level is not only related with net rainfall in that region. It is not directly related with rainfall in the region. It is related with rainfall, geology of the area, percolation in the soil, lineaments, the water extraction from the ground, and exactly what is the relationship with each input parameter, that is not known. Not there is non-linear any kind of relationship structure is not known. So in these cases, if you are using machine learning, you can improve the results. But in the cases where relationship is properly known, you should not go for machine learning. Because if relationship is properly known, then obviously traditional methods will give better result. For example, if you want to find out relationship between force and acceleration, you should never go for machine learning, because relationship is known. It is uh, properly known, force equal to mass into acceleration. So there is no point of using machine learning. There is no point of giving a lot of training data and doing the relationship identification. It's simple, force equal to mass into acceleration. Use that. That will be more accurate, not machine learning. So you should go for machine learning where a problem is not solved with the help of traditional algorithms. Not solved means not 100% solved. There is a possibility that non-machine learning algorithms are giving 90% accuracy, 95% accuracy. With the help of machine learning, you can improve in different conditions. Then comes, can you formulate the problem properly? So once you have decided that you can use machine learning, you should be able to formulate the problem properly. Like if you are interested in groundwater level identification, you should be able to identify the factors. You should be able to narrow down to the factors related to groundwater level. Then only you can proceed. So there may be the case where you think that you can apply machine learning for air quality prediction. That is one statement. Use machine learning for air quality prediction. But how air quality is dependent on the input parameter? Basically, what are the input parameters for air quality? And once you narrow down to input parameters, you should be knowing the availability of data for those input parameters. So like for air quality, pollution from vehicles, pollution from brick kiln, pollution from industries. So these are some of the input parameters. But do you have any observation of them? If yes, then only you can proceed for application of machine learning. Otherwise, so the important thing is problem formulation should be very clear. Then only implementation can be done. Once problem is formulated, input data is available, you need to think about the sufficient examples. Why do you need sufficient examples? Because here you need to do training. And training you can do when you are having the feature vector as well as labels. So you need to have sufficient example. Basically, from this, you need to have sufficient example means I want to say you need to have sufficient historical data. So also you need to look that is there any pattern, is there any relationship between input data and output data. If there is some relation, then only you can perform some prediction algorithm. Otherwise, if regular pattern or completely irregular pattern exists between input and output, then the if which means if there is no pattern, what will you identify with machine learning? With machine learning, a pattern is being identified from the training data, and the process of identification of pattern is learned from the training data, and that is applied over the future data or testing data to reveal the patterns in that. So if there is no pattern, no regular pattern, you should not go for machine learning. So then can you find a meaningful representation of your data? Is availability of data, as I was talking, that for air quality, like industrial pollution, pollution from vehicle emission, brick plane. So these are the some input data, but do you have any representation of these data sets? If yes, then only you can apply, otherwise you cannot. Then how do you define success? How do you define that you have successfully applied machine learning? So basically, criteria accuracy assessment process is needed to define the success. So machine learning application exists in RSGIS in the form of image classification, time series data, application in case of forecast. So here is the one example where machine learning is applied to predict the groundwater level. So machine learning basically can be used for the classification as well as regression both. So classification is done for categorical data and regression is done for continuous data. So if you are interested in image classification, so that is uh, here for image classification you will use classification algorithm, classification model, and for regression different kind of model is needed. So each classifier, basically if you are using random forest, so random forest has two implementation, random forest classifier as well as random forest regressor. So similarly support vector machine classifier as well as support vector machine regressor. So for classification you need to use uh, support vector classification or random forest classification, and for regressor a regressor need to be used. So here groundwater level need to be predicted. So for that groundwater was collected for this entire region. Groundwater is available in some region. Groundwater level is available with some agency, so it is taken from there. And how groundwater is related with other parameters, that is made in this fashion. So I'm just telling one example how training data is made. So here this data I got from the agency which collects the groundwater level. So here I am having the location of groundwater, type of the site. There are four categories of the site type: dug well, bore well, something kind of category codified in the form of numerical values 1, 2, 3, 4. As I told, a model takes only numerical values, then which year water level was observed and how much water level was observed. So this was, and in which season the observation was done. There are 4, 5 seasons: pre-monsoon, post-monsoon, winter season, summer season, something like that of seasons are there. Again, converted to 1, 2, 3, 4, one for pre-monsoon, two for post-monsoon, that way. Then here, uh, input parameters like the or the parameters on which or inputs on which water level is dependent. So as you know, water level depends on the rainfall. Obviously, if there is a very good rainfall, water level is expected to be good. If uh, percolation is good in that region, so it is also expected here the rainfall of not only 1 year affect, rainfall of previous 2, 3 years affects the water level. Suppose previous year there was a great rainfall and this year there is less rainfall, but because of the previous year's great rainfall, water level of this year will be better. So that is why previous 4, 5 years, 5 years rainfall was considered. For example, here in 2017, water level is observed uh, this much. So for this previous 5 years rainfall was considered, then in which season rainfall was there, then now the parameters, different inputs on which water level depends, the AESR and depth, they are soil related parameters, then geological parameters, fold, fault, uh, dike, then uh, drainage availability in that region, basically river, distance from that, erosion category, soil texture, lithology, because these things define the percolation category. Then distance from built up area, distance from built up area, distance from water body. These are some of the parameters considered for this small study. So later on for training these parameters, uh, sorry, for training water level is the label value we have discussed here, right? We have seen what are the terminologies. So label is the water level here, and other than this, rest of the things like previous year's rainfall, elevation value, soil properties, geological properties, all those are feature vectors. So for training process, uh, the kind of data I have shown, that data is given to the training. The inputs or feature vector, and corresponding to feature vector, the water level value was given. So from this process, we have got a model, and later on, right now here you can see uh, there are around 66,000 input data sets. So from this, few like 1,000, 2,000 points were used for training, and rest of them are used for uh, prediction. So that kind of process was used. Some points were selected from this input data set, and those were used for training, and some left for testing. And using these points, prediction of water level for year, a particular year was done. So here, uh, So you can see on the x-axis it is the observed water level, and on the y-axis you can see it is the predicted water level. So accuracy is good enough here. So you can see here it is 20, and on the predicted line also it is between 15 and 20. So deviation is not too much, up to 4 5 meters deviation is there, but still it is a good try kind of thing, because groundwater uh, level prediction is very difficult because of the non-linear relationship, and because of its dependency on multiple things: rainfall, geology, soil texture, people living in that area, basically groundwater extraction, availability of rivers or water bodies, then uh, agriculture pattern. So it depends on many factors. So since this was just for a case study kind of thing, so it is good for showing the example that what kind of things can be done with the help of machine learning in GIS. So I think with this, I will stop the class. I will give you 5 minutes. You can write the questions, then we will answer the question. I will answer the questions. Thank you. Welcome back. I can see some of the questions. One question is, where can I find information about application of machine learning for natural resources? There are certain books on Springer I have seen. You can simply search on Google application of machine learning for RSGIS Springer. So you will get the result. I don't remember name of the book exactly, but there are books for RSGI application. Oh, sorry, machine learning application to RSGIS. And another question is, are there applications for urban phenomena like city growth? Yes, for city growth, machine learning can be applied very well, but you need to only find the input parameters. Uh, Basically, feature vector, if you talk in machine learning terms, you need to find the feature vector. Basically, the urban growth depends on which uh, inputs. So those things you need to find out and uh, train the model. You will get. You can try. So there is relationship between input and can be checked by. Yes, the relationship between input and output data. If you plot the data, you will be able to see the relationship. If you are plotting, suppose you are plotting input data, suppose you are plotting input data and output data and x and y axis, the just plot make scatter plot. So if there is a straight line kind of relationship, your input plots will be input points plotted will be following this kind of pattern. If there is some non-linear pattern, accordingly it will points, basically input points will be following that kind of pattern. If there is no relationship between input and output, you will find that your input and output, they will be distributed in a circular form. which means there is no relationship. Yes, very good question is asked. What is model overfitting? When your model response is very good with respect to training samples and poor with respect to testing. So this happens when your input data is not, sorry, when your future data or testing data is not identical with the distribution of training data. So in that case, it is called model overfitting, which means, so if you remember, I have told one example, this kind, where suppose data distribution is like this, and you are taking data from this region only for training data. So in this case, you will get training accuracy maybe for 99%. Let's say accuracy is 99%, but when you will do the testing with this data, your accuracy will be significantly different, maybe 50%. So in this case, it is the example of overfitting of the model. Success rate curves are required to check about the success of the model, that it is overfitting or underfitting kind of analysis. Another question is, how can I get input data for landslide prediction? So for this you need to first narrow down to what kind of data is responsible for landslide. So I'm not a geology expert, but some guess I can make. For landslide, there need to be a heavy rainfall. Slope of the region matters for landslide. Then road matters. If there is a road, a landslide may occur because to make the road, cutting off the hills happens. Then river neighborhood also matters for landslide, because when there is river, it will do some cutting of the sides. So that may be few reasons for the landslide. So for river information, you can simply digitize, or you will get from the OpenStreetMap. Road information you will get from OpenStreetMap. Then uh, slope of the region, you can generate slope from digital elevation model. Then another important factor is the rock type itself. What kind of rock? Soil properties also matters. The soil data you can get from NBSS, National Bureau of Soil Survey. Geologic data you will get from GSI. So that way, first you narrow down to what kind of data is needed, then you can look for the search. By this, I hope you will get the idea what kind of data is available. One question is, in what format data should be and how to input data in GIS software. Input data for GIS software is like images or vector data and raster data. There are formats for raster data, TIFF file, IMG, ECW, and for vector data, popular formats are like file, geodatabase, personal geodatabase, SQLite data, SpatialLite, then GeoPackage. So these are the formats in which data is stored in GIS. So for using this data for machine learning, algorithm need to be written to read the data. If it is ready-made available software, then some software supports many data format. They can simply create the training data in background by using sample location as well as satellite imagery. So it depends on the software. And if you look for Python implementation for like TensorFlow library, so in Python implementation, you need to give data in the form of arrays. So some pre-processing is needed to extract the data for sample locations and convert it in the form of arrays. So if you remember, I have shown one Excel file. So for doing machine learning in Python, from the Excel size data need to be read and uh, need to be converted in the form of array, and then machine learning model will take in Python. And by the way, that Excel file was made by extracting data from the location corresponding to well location from the satellite imagery. There are many satellite imagery used like built-up areas, distance from water body. So distance from water body is a raster file. So what is the distance from water body corresponding to a well location? So what is the distance of well from a water body? So that kind of data is extracted from the raster images and put in the form of Excel. Then it was fed to the machine learning. Another question: how to get input data for landslide prediction or for any environmental disasters? So which data you need? First you narrow down to that. Uh, some data set I have told how to get data sets related to disaster, like rainfall. Rainfall you can get from IMD, that is a graded data of 0.25 degree. Yes, something that kind of. If you need high resolution data, you can use data from weather stations to interpolate and improve, or there are interpolated data sets given at 1 kilometer spatial resolution from world claim Chelsea. These are some of the sources from which you can get environmental data sets. So I think that's end of the lecture now. Thank you for your attention.